So we left the last video with an error in main activity when we tried to call the putExtra function. You can see the error on line 50 on screen. Now I said that putExtra can be used to add more complex objects to the intent, but there is a condition that the object must meet for it all to work. Now that object has to be serializable. Now there's a good description of what that means in Oracle's Java documentation, but rather than going straight to the page, I'm going to just search for it in Google. So we'll do a search for Java Serializable. And there's a likely looking link right at the top there. But the actual second one, Serializable Objects, the Java tutorials, is the one that promises to be the most informative. And in actual fact, I'll just go back there because the description really has enough information on the screen there. To serialize an object means to convert its state to a byte stream so that the byte stream can be reverted back into a copy of the object. So if an object is serializable, it can be stored and retrieved. Now a byte stream can be saved to disk or held in memory. We don't know exactly what the putExtra method will do, but in this case it doesn't matter. As long as it can serialize our object, it can store it in the intent for the new activity to retrieve. Now I'll go ahead and go back into that link again, because the full page may tell us how to make our photo objects serializable. So that's handy. The second sentence tells us that a Java object up here, so a Java object is serializable if its class or any of its superclass implements either the java.io.serializable interface or its sub-interface. So basically all we have to do here is make our photo class implement that interface. So let's go back to Android Studio and do that. So we're going to go back to our photo object. Sorry, our photo class I should say. And what we need to do is make this serializable. And to do that, we just come down here. What I might do is make a bit more space. And on the end of that, after the closing parentheses, I'm going to put colon, serializable. And it's java.io. Now in Java, that's all we must do, but there's one other thing that we should do, assuming that works, of course. Things are changing all the time, and a week after I first typed that code, Android Studio gives an error instead of importing java.io.serializable. Now, if it was just a case of typing the import in manually, I'd probably have stuck with using serializable, but as well as causing that error, JetBrains have added a really neat feature to the Kotlin plugin. Now, JetBrains, in case you didn't know, are the people who produced the Kotlin language. Now, I've got a bit of a quandary now. Do I show you how to implement serializable correctly, or do I show you that neat feature instead? So we've decided to do both. Now, this isn't something that we'd normally do, but there's a lot of comments on the internet about serializable being slow on Android. Now, that can be true. There's another interface that can perform a lot better than serializable. That other interface is called Parcelable, and we'll come to that next. Now the reason I'm going to show you both functions is because serializable can also be faster than parcelable. It depends on the structure of the object being serialized. And it also depends on serializable being implemented correctly, which often isn't done. Now serializable is very easy to implement. As I said, all that's absolutely necessary is to add the implementation to the class declaration. So that's in Java, but in Kotlin that's no longer enough. Now, JetBrains are working on building Kotlin support for serialization, but that's not yet ready. So if you want to use it, we'll be using the Java serialization interface. Now, to specify that, rather than the Kotlin interface, we just add the import manually. Now, you can see in the case here, when I selected, or rather when I typed in serializable, I selected java.io in the pop-up, and you can see up here that under the import, we've got java.io.serializable. So if you do get an error, that removes the error and we can carry on creating our class. Now Java code can run on many different platforms using different versions and types of the Java Virtual Machine, or JVM. Google have written their own JVM, Dalvik, on earlier versions of Android, and Art on the later versions. Now if you rely on the default implementation of serializable, then the data may not be recoverable using a different virtual machine or version of Java. Now, strictly speaking, that's not going to be a problem here, and that's because our serialized photo objects will only be used within a single app while it's running. But it's always a good idea to do things properly. So you may, for example, decide to provide a bookmark feature to allow users to store certain photo details in a favourites file. And if Google subsequently update the version of Java or the JVM, then your favourites may not deserialize correctly. Now, considering how easy it is to fix that issue, there's really no reason not to do that. So all we really have to do is add a serial version UID to the class. Now that needs to be a static field in Java, so that means we have to use a companion object in Kotlin. So I'm going to add that to the start of the class, just after the definition, before the override to toString. So we're going to type companion object, press enter there so it's to write some of the code for us. We're going to type private const val, and it's going to be serial. The spelling and case is very important here. Serial version UID equals 1L. So it's serial version UID. Now, the version number is used by the serialization code to check that the data it's retrieving is the same version as the data that was stored. Now, if you don't create your own serial version UID, then Java generates one for you, and different versions of Java may generate different UIDs. And that's why you can get problems by not defining your own UID. Now, because that's so easy, many programmers just implement serializable like this and then complain that it's slow. Now, with a simple class like this one, this basic implementation will work just fine for what we want to do with it, especially on modern devices. But the problem with performance arises because the JVM has been given no indication of how to serialize our class, so it has to use something called reflection to work it all out. Now, reflection involves examining the class at runtime to work out the fields that need to be stored in the byte stream. Now, we can do a lot better than that by implementing 3 additional functions. Now, the details of these are as described in the documentation for java.io.serializable, and the quickest way to get to that is just to control-click on serialization in our class declaration. In the case of a Mac, I'm just going to do a control-click. Now, I'm not going to go through this Java doc, but if we scroll up into around about line 60 from memory, there's the 3 functions that we should implement. So we're going to start with writeObject, which puts the value of our class properties onto the output stream that's used for serialization. So I'm going to close that down. And back in photo, we're going to do that. So we're going to type in this after the toString function that we've written. So we're going to start with an annotation, at throws, parentheses, IO exception, ::class. Then we're going to start with the definition, which is going to be private, fun, writeObject. That's that first one. And it's going to be out, java.io.object, output stream. Then we'll start with a log, so log.g, parentheses, tag, and this time we're just going to type photo because we haven't actually created a tag constant here, and do a writeObject called. Then we're going to do out.write UTF, parentheses, title. I'm just going to copy that, the remaining fields. We need to do author ID, link, tags, and image. The next one is going to be author ID, then we want link, next we want tags, and finally we want image. So that's the Kotlin equivalent of the Java signature that the function must have. Now, I've logged when it gets called, and then we just write each of our properties to the stream. Now, the next one's a complementary function to take data off the stream and set the values into our class properties. So let's go ahead and do that one. We'll start with an annotation again. So at throws, parentheses, can be IO exception, ::class, comma, then class not found exception, ::class. Then the actual function definition will be private, fun, read object, parentheses, in stream, that's going to be java.io.object output stream. And the code, we're going to do a log dot D, photo again, comma, read object called. And the code's going to be title equals instream dot read UTF. I think that should be object dot input stream. Let's try that. Just stick the last one there. Okay, author is equal to instream dot read UTF. Then we've got author ID equals instream dot read UTF. Link equals instream dot read UTF. Two more, we've got tags equals instream dot read UTF. Then the last one is image, so image equals instream dot read UTF. Now we've got an error on each line when we try to assign the value from the stream to our properties, and that's because all the properties were declared as val, so we can't change them. So to fix that, we just have to declare them as var in our primary constructor, or in the primary constructor. So let's go back and doing that. So we're going to do that to all of them. So var, 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 and last one, image, var. You can see that fixes the errors. Okay. Now the last function that we now have to implement is the read object, no data. So let's write that one now. So it's going to be at throws parentheses object stream exception colon class, and the function definitions of private fun read object no data parentheses, and it's going to be just a log.d photo comma read object no data called. Now don't worry too much about this function. It's intended for rare cases when you've created a subclass of the class that was originally serialized. Now we're not doing anything in this function. I've included it so you can see the Kotlin signature for all three functions. So when we provide these three functions, the JVM no longer has to try to work out what goes where when serializing or deserializing the data. So this makes the process far more efficient. All right, so at this point we should find that the error is now fixed back in main activity. Let's go back and check that out. And we can see the intent.putExtra has no longer got any errors. Now in main activities on item long click, we're using the putExtra function to store a photo object in the intent. Now the key we use comes from the photo transfer constant defined in the base class, and we talked about that before. Now we get the photo details by using the getPhoto function of the adapter and telling it the position of the photo we want. And we have to start the activity, which we do by calling start activity. You can see that happening on line 51. Now what we haven't done yet is written the code to download and display the full-size photo, but we can run the app to make sure that what we've done works so far and that there's no errors. So let's go ahead and do that. The list can be scrolled as it could be before. When I tap on an item, we can see the toast message should still appear, which it is, as you can see there. So we haven't broken anything so far. So I'm going to try a long press now, and let's do that. And you can see that at this point, there's our photo details activity launched. Now it's just showing the placeholder at the moment, but we have got it launching successfully. Now we've also got the home button in the toolbar as well, so that bit's also working fine. Now the button doesn't work though if we try clicking it. Clicking it should take us back to main activity, but that's not working. The back button down here though does work, but again you saw that the home button doesn't. Now the reason that the home button's not working is that we didn't use the hierarchical parent option when we created the activity from the wizard. So we ticked it for search activity, but not for photo details activity. So let's have a look at what it did when we ticked that option and chose main activity as the parent for search activity. So I'm going to open up the manifest. I'm going to close down the logcat for now. And we can actually see the differences between the two, between the two activities, the search activity and photo details activity. Search activity's got an extra attribute in its tag and also a metadata tag. Now these tell the Android framework that search activity's parent is main activity, so it knows where to go back to when the home button's tapped. Now that's all that ticking the option in the wizard actually did. But if you forget them, then it's very easy to do it manually afterwards. So I'm going to go ahead and add the parent activity name attribute to the activity tag and copy the metadata. So I'm going to start over here. I'm in the search activity. So I'm going to copy this line here, this Android parent activity name equals main activity. Copy that. I'm going to come down here and put that into photo details. I'm going to put it right at the end here after photo details, after the label, in the same place as it is currently in the search activity. Now the other thing we need to do is copy this metadata. So let's go ahead and do that as well. I'm going to copy that and put that below down here after the no action bar line. So if we run the app again now, and we'll just test that the home button now works. So I can do a long tap and click on the home button, and it now goes back to main activity correctly. So that's working well. All right, so let's finish the video here. We've still got a bit of work to do. In the next one, we'll start talking about how to get the photo details activity to display the photo. So I'll see you in the next video.